Hello guys, welcome to PLC Goods video tutorial. In this video we will start to learn how we can program Logix 5000 family of Allen Bradley controllers. First we will have a short introduction. Then we will use RSLogix 5000 and RSLogix Emulate 5000 to write and test a simple program on our computers without any real PLC. Until now, we learned basic instructions and features of RSLogix 500. We can use this software to program and configure SLC 500 and MacroLogix series of Allen Bradley PLCs. Now we are going to learn how we can use RSLogix 5000 to configure and program the RSLogix 5000 family of Allen Bradley controllers. Let's do a simple project which uses a push button to turn on a lamp. Note that this simple program is generated in ladder language. Like industrial circuits, suppose this is a virtual power line. I need to connect this contact to a digital input address, which is connected to a push button. So when I press it, PLC closes this contact in my program. In consequence, the virtual power reaches the output coil. So if the output coil is connected to a digital output address, which is connected to a lamp, PLC will turn it on. I use RSLogix 5000 to write this simple program. Then I will use RSLinx to make a connection between my computer and a virtual PLC station, which I can create it by RSLogix Emulate 5000. Let's launch RSLogix 5000. Now, let's create a new project. Notice that this software is similar to RSLogix 500. Here we can select the PLC mode. In this window, I can manage my project. For instance, we can double-click on the main routine to write a program or configure our PLC hardware under the I/O configuration submenu. Here we can see the instructions that we can use to write a PLC program. Here is the working area, which we can use to write and modify a PLC program. Now let's see how we can have a virtual PLC station using RSLogix Emulate 5000. Here is a virtual chassis. I can right-click on each slot to insert a controller or an input-output simulator. Let's select Emulator RSLogix Emulate 5000 controller to have a virtual PLC. Here, let's reset the configuration to its default values. Here, pay attention to the selected version. I select version 20. I will need to use this number in RSLogix 5000. Let's keep these parameters and click on Finish. Obviously, a virtual processor is added to my virtual chassis. Similarly, let me select the 32-point input-output simulator item. Well, I prefer to reset the configuration to default values, then select a name for the new virtual input-output module. Obviously, you can add processors or input-output modules onto each slot or remove them. Now let me use RSLinx to connect my computer to a virtual PLC station. Now let's click on this icon, Configure Drivers. To make a new connection, I need to select the Virtual Backplane option to make a connection between my virtual PLC station and RSLogix 5000. Now I click on Add and select its default name. Here I can change the RSLinx slot number. Now its slot number is 0. Let me change it to 5 to see its result on my virtual chassis. Let's use a slot number 0 for RSLinx. Okay, the created driver is in running mode and RSLinx has detected my virtual PLC and its modules. Let's open RSLogix 5000. I need to configure my virtual PLC station in RSLogix 5000. First, a suitable processor should be selected. Here are two ways to change it. The first way is to create a new project. Here in this menu, I need to select RSLogix Emulate 5000 controller as the processor type. Notice I selected version 20 for my virtual processor, so I select it here as well. Now let's write a name for the new controller. Here I need to select a suitable chassis type. My virtual chassis has 17 slots. Pay attention, the virtual processor is installed on slot number 2, so I should change the slot number to 2. Now I can change this path where the project will be created. Now I can click on OK, but let me click on Cancel to show you how I can change the selected controller inside my current project. Right-click on the current controller and then click on Properties. Now click on Change Controller. At this window, select a suitable controller and its software version. Here there are two errors because I didn't assign an address for this output and its previous contact. I will determine their addresses later. Let's continue and add my virtual processor to slot number 2. So I need to select this number here. I selected the suitable controller for my current project. Now I am going to configure this module in RSLogix 5000. Right-click on the chassis and select New Module. At this window, all valid modules are divided based on their category and vendor. Let me select the other category group to add this module to my project. At this window, let's write a name for the new module. Then I should determine its slot number. Note that I installed the input-output module on slot number 3. On the right side, there are some connection parameters. You can fill them like me. Pay attention to these numbers, which determine the input-output size. Based on the current settings, the inserted virtual input-output module supports 64 digital inputs. Note that if you right-click on each module to select properties, you can change its settings as well. Let me change the request packet interval time from 5 to 50 milliseconds. Okay, I configured my virtual PLC station. Now let's complete the program. I need to use an input and output address for the inserted contact and coil. Let's go to the virtual PLC station. Right-click on this module to select properties and click on the I/O Data tab. Here I can change and view the states of 32 digital inputs and outputs. How we can use these digital inputs in a program? Now in RSLogix 5000, double-click on controller tags. Here you can see a table related with the configured input-output module whose slot number is 3. Obviously, this table has 3 rows associated with the configuration input and output bits of the inserted module. Notice I entered number 2 as the input size. So here you can see 2 rows. Okay, to use these digital inputs in my program, I should use the second 32 bits. For instance, I'll use the first digital input to activate the output. Here I write start as a short description for the selected digital input. Similarly, let me show you the output digital addresses. To use these 32 digital outputs, I can use these 32 addresses. I want to use the third digital output address. Now let's double click on main routine to view the program code and to use the selected input-output addresses. Now let's compile the program to ensure there isn't any error. Now click on Communication and select Who Active. Obviously, I can connect RSLogix 5000 to my virtual processor. Let's select it and download the program. Let's select the Run mode. Now let me activate the first digital input. Note that based on my program, my virtual PLC turned the third digital output on. I hope you have learned how to create a virtual PLC station with RSLogix Emulate 5000. Now, after a short introduction, I will introduce my PLC hardware and show you how RSLogix 5000 can be connected to my PLC via its serial port and Ethernet module. I used RSLogix Emulate 5000 to create a virtual PLC station to test a simple program. Now we are going to see how to connect my PLC to my computer via its serial port and its Ethernet module. First, let me introduce my PLC hardware. There are two types of PLCs, compact PLC and modular PLCs. In compact PLC, the capability of the I/O module is fixed. In compact PLCs, power supply, CPU module, and some input-outputs are integrated together, like my MicroLogix 1500 PLC. A compact PLC may be the most economical option for a specific application requirement of a machine, but they are not a good choice to control large and complex industrial processes. Also, we can use modular PLCs, which are known as rack-mounted PLCs too. In a modular PLC station, several components such as a CPU module, power supply, and input modules are fitted on a chassis or rack. So we can maintain and repair a modular PLC station easier than a compact PLC. Usually, they have more memory and capabilities to store data. Also, modular PLCs are a good choice for future industrial expansion and growth. But a modular PLC station is more expensive than a compact PLC. Let me introduce my PLC hardware. First, I have a chassis that holds my modules. Also, it provides a connection between different modules for transferring data, and it has its own power supply module. It converts an input source power into a voltage required for a PLC internal circuitry. The power supply module converts the input source power into a signal level voltage used by the PLC processor and other modules. My next module is a communication module. I can use this module to connect my computer to a PLC station via an Ethernet network using a simple LAN cable. The next one is my CPU module, which it supervises all operations within a PLC station. After the CPU module, I have installed an analog input-output module. It receives 4 voltage or current analog signals and it converts their signal levels into a digital number that can be stored and processed by a CPU module. Also, it supports 2 analog outputs. So my CPU module can use it to generate a suitable voltage or current to control analog equipment. The next two modules are digital I/O modules, and output modules can control devices such as relays, motors, and lamps. An input module can detect the status of digital devices such as push buttons, switches, and temperature sensors. The digital input module is my last module. After that, I don't have any special modules, so I have used empty slot filler modules to protect my chassis from dust, water, and other unwanted events. Obviously, each module has a small LED display. Here, the communication module shows its Ethernet, IP, or MAC address. Or my CPU module shows its mode, which can be run, RAM, and program mode. Or here, we can see which output or input is activated. As I mentioned earlier, the processor or CPU module controls other ones and it can be programmed. My processor model is Logix 5562. It has a mini switch to change its mode. I can use its serial port to connect it to my computer, and this is its battery, which is used to keep and maintain the real-time clock and power its memory chip that contains the system configuration file. Please pay attention to slot numbers. These numbers will be used during the programming steps. Now let's see how we can connect to the PLC station with its serial port. Let's launch RSLogix 5000 to program my PLC and use RSLinx to make a connection via the serial port. Let's click on this icon, Configure Drivers, to make a serial connection and select RS232DF1 devices and click on Add New. Here I can change the new connection name. Here I can see my only serial port number, which is COM1. Note that I have connected to my processor port with a serial cable. In this menu, I should select a suitable device. Let's select Logix 5550 Compact Logix and click on Auto Configure to detect the connection settings automatically. The status of the new connection shows in running mode. Obviously, RSLinx has detected my processor, its chassis, and other modules. Let's continue the video with RSLogix 5000. We have created a new project, configured a virtual PLC station, downloaded and tested a simple program. Now, let me tell you an easier way to configure your PLC hardware using the project data which has been transferred to my PLC memory already. Let's open the communication menu and select Who Active. Here I select my processor via the created serial connection. Now I click on the upload item so the project data like the PLC program and its configuration data will be transferred from my PLC station to my computer. Here I can see the general data of my PLC station. Also in this tab I can see its revision. Then I click on Select File to determine the project name and where the project should be saved. Now the project on my PLC station is transferring to my computer. This is my PLC hardware configuration. Now let's see what my PLC program is. Let's modify this program and download it to my PLC. I cannot change the program because I am in online mode. For modifying a program, I should be in offline mode. Now I can modify the current program. I want to use my first digital input module which is installed on slot number 4. Let's change this address. I have installed my digital output module on slot number 3. Let's use its first digital output. Now let's compile and download the new program. Maybe there are several connections in this window. I can select one of them and click on Set Project Path. After that, RSLogix detects the selected connection as its default connection to download or upload projects. First, let me change my PLC mode from program to run mode using its mini switch. Now let me activate the first digital input. Based on my program, PLC has turned on the first digital output. Now let's see how we can download or upload a program via the Ethernet port. Some processors have an Ethernet port, but my processor only has a serial port. So I have installed an Ethernet communication module beside my CPU module. I am going to show you how I can upload and download a program with this module. Pay attention. I am in online mode via the serial port, so I can see my Ethernet module properties. Let's select the port configuration tab. Here uncheck this box, enable BOOPI. We know that each device has a specified IP address on an Ethernet network. My processor IP address is 192.168.1.13. Now I can change it. Note that the IP address and its subnet mask must be similar to my computer's IP address. Here you can write CMD to see your computer IP address. In this window, write ipconfig. This is my computer IP address and its subnet mask. So let me use these values for my processor, but the last number of the IP address must be a different number. I can see the IP address of my Ethernet module on its LED display. Let's go to offline mode. Now I want to make a new connection using my Ethernet module. So I close all opened windows to start the connection process from its first step, which starts with opening RSLinx. First, let's stop and delete the previous serial connection. Pay attention. Until now, we have learned to create, use, and delete a serial connection to download or upload our projects. Now, I am going to use my Ethernet module to make a connection with my PLC. In the next videos, I will use my Ethernet module to connect my PLC to my computer and use its serial port to connect my PLC to an HMI device. Let's continue to make an Ethernet connection. Let's click on Configure Drivers and use this menu to select the Ethernet IP driver item. Now let's click on Add New and use the default connection name and click on OK. In this window, select Browse Remote Subnet. Here write the Ethernet module IP address and its subnet. The new connection is in a running mode. Under the Ethernet connection, RSLinx has detected the PLC hardware. Now let's open RSLogix 5000 and upload the previous project from the PLC to my computer. Similarly, let's go to this menu and select Who Active. In this window, select the Ethernet connection and its detected processor. Now I can upload the previous project from my PLC to my computer. My PLC is in run mode. Let's see its program. Note that we downloaded this program via the serial port and tested. Let's test the program again, but at this time RSLogix 5000 is connected to my CPU module via the Ethernet module, not the serial port. Okay, until now we have learned how to download and test a simple program. We will continue learning Logix 5000 controllers. I will show you how my PLC hardware can be configured in RSLogix 5000 software. I will give you tips to help you to configure your PLC hardware during the video. After that, I will use EKTS software to simulate a simple industrial circuit to turn on a three-phase motor. We learned how RSLinx can be used to make a connection with a virtual PLC or how to use it to make a connection between our computer and PLC via its serial port or Ethernet module. Now I assume you are able to download and test your PLC programs using either a virtual PLC or a real one. Otherwise, please watch the previous videos again. Now let's open RSLogix 5000. We uploaded a project from PLC to RSLogix 5000 in the previous video. The project had all the necessary information such as its hardware configuration. In this video, I am going to create a new project and configure my PLC hardware from the beginning. Here I select my CPU module type, which is a ControlLogix 5562 controller and its revision. If you don't know your CPU module revision, open RSLinx and right-click on your CPU module to select Device Properties. Here you can see your revision number. The revision number of my CPU module is 17.002. So under the revision menu, I select the number 17. If you have redundancy in your CPU module, select redundancy enabled. But what is redundancy? Redundancy is about having backup components like a CPU module in a system that can take over when the primary components fail. I have only one CPU module, so let me skip the redundancy item. Here I write turn on motor as my controller's name. If you want, you can use this box to write your description of the project. Let me skip it and select a suitable chassis type. My chassis has 10 slots and I have installed my CPU module on slot number 1. Let me use the default path address and click on OK to create my new project. I created my new project and here I can see its name. Also, I can select my controller and see its properties or change the controller type. After creating the new project, the next step is configuring the PLC station in RSLogix 5000. In the previous video, I uploaded my hardware configuration and its program from my PLC. I always recommend uploading PLC data to your computer before changing anything in your system. Now let's configure my PLC hardware. I determined my controller type when I was creating the current project. Now let's right click on the chassis and select new module to insert a new module. Here, all modules are divided according to their category. Let me find and insert my analog module. Its model is IF4 FXO F2FA. In this window, I need to determine some information. First, let me assign a name to my analog module. Then I need to determine its slot number. Let me skip the description box. Inside the next field, COM format, I can see some configuration options for my analog module. For instance, if float data is selected, then the module returns floating point numbers. Or if CST, time stamp float data, is selected, then the analog module returns a floating point data with the time of the system clock when the data is sampled. Let's select the default choice, float data. Inside the revision field, make sure this number matches the label on the side of your CPU module. The electronic keying feature automatically compares the selected module with the physical module before starting I/O communication. This feature can prevent communication to a module whose type and revision do not match or configured hardware in RSLogix 5000. Compatible keying is the default setting. By selecting this choice, we can replace a module of a certain major revision with one of the same catalog number and the same or a higher major revision. If a major revision is the same, then make sure that the minor revision is the same or higher than it is configured in the project. Now let me click on OK to insert the analog module into my project and open its properties window. I can see general information about the inserted analog module in this window. For example, here is the request packet interval time. It specifies the period at which data is updated over a connection. Also, I can select the Input Configuration tab and change the input range of each channel. Let's use default settings and continue configuring the PLC hardware. Now I am going to define my digital output module, which its model is OB32. Here I should select its major revision. I can find it on my module, but let me use RSLinx to find it. The major revision is 2 and the minor revision is 4. So I select number 2 as the major revision as well. Here I assign a name to my digital output module, specify its slot number and change its minor revision to 4. In this window, I can review and change some of my digital input properties. Let me use the default settings and click on OK. Now I want to insert my digital input module. Its model is IB32B. I can click here to find my module. Let's assign a name to my digital input, select its slot number, and specify its minor revision. Finally, let me insert my Ethernet module. Note that after specifying the slot and revision number, here I need to assign an IP address to my Ethernet module. Let's use default settings. OK, I configured my PLC hardware. I can right-click on each module and change its properties. For instance, the Inhibit module option closes the connection between the selected module and its owner controller. Note that when a module is inhibited, a warning icon appears on it. Also, when a communication fault happens. You can select this checkbox if you want to have a major fault on the controller when there is a connection failure. Note that for a digital output module in the Configuration tab, you can configure two modes, Program and Fault. Here I can select the desired state for each digital output, on, off, or hold its last state when a PLC is in program or fault mode. Note that to use the second column, fault mode, I need to activate this item. Change output to fault mode state. Let's use the default settings and go to the Configuration tab of the Digital Input module. Here I can enable or disable any digital input. On the right side, some digital input filter time are used to smooth input noise transient in each digital input. I mentioned some important points for configuring PLC hardware. The default settings are usually suitable for many applications, but if you want to change the settings of a module, please read the user manual published by its vendor carefully. Now let's start the programming steps. Here I can write my program. Before writing a new program, let's simulate a simple industrial circuit using EKTS. This circuit uses two normally closed and open push buttons to activate a relay, which its contacts are used in the control and power circuits. In normal condition, these contacts are open. When I press the start push button, the electrical power reaches the relay. At this time, the relay changes the state of its contacts to pass the electrical power, even if I release the start push button. In the same time, these contacts pass the electrical power to a three-phase motor in the power circuit as well. Note that PLCs are used in control circuits. They can turn on low power devices like signal lamps. Also, they can use relays to turn on devices like three-phase motors. I can use this simple program in my PLC to use two digital inputs to turn on an output like the left circuit in EKTS. Obviously, its logic is similar to the control circuit in EKTS, but there is an important difference. In the left circuit, if I want to use other devices like timers, I have to change the circuit wiring, but on the right side, I only need to change the PLC program, not its wiring. Let's write this simple program. In RSLogix 5000, usually we use this menu to find and refer to an address of our input-output modules. Now let's use an address of my digital input module whose slot number is 4. So I must find local 4 in this menu. Here, based on the module type, you can see any of these three letters, C, I, and O. Now I want to use a digital input address, so I select local 4:I. Here, the fault bits can be used to detect if a fault happens in any digital input or not. I want to use a digital input, not its fault state. So let's select local 4I data. Now I can select any input of my digital input module. Let's use the fourth digital input. This digital input will be used to turn off my output. So let me write a stop as its description. In this table, I can find all valid addresses. Let's continue to complete my program. Here I want to use another digital input. To see this address in the controller tags table, I can click here or on the left side double click on controller tags. Let me find the digital input address and write start as its description. Also, I need to use an address of my digital output module. Let's use the first digital output whose address is local 30 data 0. Okay, I have completed the program. Now let's compile the program. Now let's download the program to the PLC. Here I have two connections with a virtual PLC created by RSLogix Emulate 5000 and a connection with my real PLC using its Ethernet module. I prefer to use the PLC, so let me select this connection and click on Set Project Path to select it as my default connection. Let's download the program. Let's change my PLC mode to run mode. I can use the fifth digital input to turn on the first lamp and the fourth digital input to turn it off. Okay, we have reached the end of this video. In the next video, I will modify this program and we will learn how to use Factory.io software. Factory.io helps us to simulate a real project. Thanks so much for watching.